numbers don't total 100, then you've got a problem. They have to total 100. So don't make it total more or less than that. Okay, another good question might be to draw this diagram. I might give you a circle representing the Earth, and then you'll have to draw the atmosphere around that. So the atmosphere is that envelope of gases that we talked about. And there is certain characteristics of the atmosphere that divide it into layers. Do you remember what characteristic it was that divided the layers? It was whether it warms towards the top or cools towards the top. So they're defined on the basis of temperature. So the bottom layer is the troposphere, or the weather zone. Then it gets colder towards the top. You might remember that the reason it gets colder towards the top is because the surface is warm and it's putting lots of energy into that troposphere. And as you go further and further up, you get to the tropopause. The troposphere is coldest there. Then at the tropopause, you switch to warming as you increase. So as you go further away from the Earth in the stratosphere, you are actually seeing a warming as you go up. You'll remember that was because it was absorbing energy from the sun's energy, and also trapping energy that was trying to escape from the surface of the Earth. So what this means here is, for the troposphere, for instance, it's warm on the bottom, cold on the top. Then you get into the stratosphere, it's warm on the top, cold on the bottom. That's why there's a tropopause in between them. Because the way the temperature is changing with height changes right there. It goes from getting colder with height to getting warmer with height as you go through the stratosphere. Then you have the stratopause, which delineates another break in that temperature with height. So in the mesosphere, you see that just like in the troposphere, you have warm on the bottom and cold on the top. So right along this, just above the stratopause within the mesosphere, it's warm. It gets colder as you go up towards the mesopause. Then in the thermosphere, you see that it's actually warming as it goes up again. So if you're flying up, you would find it was cold here at the mesopause, and then it gets warmer as you go up in the thermosphere. It's absorbing solar radiation. So you can see that there is incoming solar radiation, which is going down to the stratopause and getting stopped here, and there's some incoming solar radiation which goes down and helps to drive a lot of the processes on Earth. You can see that all the weather is occurring in the troposphere, but some of the aerosols, particularly from volcanoes, are being injected way up into the stratosphere. Hot air balloons flying in the stratosphere, airplanes flying in the stratosphere, rocket ships leaving. The aurora borealis, some of you might be familiar with that as the northern lights. It is up in the thermosphere. So what are the axes? The temperature scale. As you are on this side, you're at minus 100 degrees Celsius, ridiculously cold. Over to here, 500 degrees Celsius. Here, the height in kilometers, so 0, obviously you're at the surface, up to 200 kilometers above the surface, way up here. So you can see, when you follow this temperature line, this black temperature squiggly line, that through the troposphere, you're warmer at the surface, you're getting colder because you're moving towards this way, you're getting colder. Once you get into the stratosphere, it was cold, and now you're getting warmer as you go up. The mesosphere, it was warm, and then you're getting cold as you go up. And in the thermosphere, it was cold, and you're warming as you go up. So there's the readings I already mentioned. So how do you prepare for